So yeah, I think that you guys do have your midterm 3 coming up. So hopefully they maybe ease up on you guys a little. I know that midterm 3 is going to at least cover not utility, well, expected utility, and it's going to cover insurance. So um, I know that I'm a little bit behind where you guys are in lecture, and that's on purpose because I wanted to spend a little bit more time covering stuff that was going to be on midterm 2 last week. So as a result, I haven't quite gotten to insurance yet, so that'll be the majority of what I do this week. And we're going to mix in expected utility. So just to kind of clarify, the way that you guys can approach expected utility and insurance in this class is you can kind of think of them as being the same. Because in terms of like the kind of questions that you'll be getting, they are very similar to each other. And correct me if I'm wrong, but will there be like consumer surplus stuff on midterm 3? I know that everything got thrown off because they added one more midterm. So maybe if you guys could just drop that in the chat so that I can better direct you guys on you know, the material that I'm giving. Also, if you guys could let me know like when it is. So is it probably next Thursday? I'm guessing like week 8. Oh, okay. All right. So we do have some time. So that's good. So without further ado, I do want to get into insurance. And I want to kind of talk about what the idea of insurance is just in general. And then we're going to get into preferences. So that's going to be how consumers decide to purchase insurance given what kind of person they are, right? And you guys will probably be more familiar with that term, what kind of person they are. So that refers to risk averse, risk loving, risk neutral. And I'm sure you've already heard that term in lectures, but we'll just kind of cover that as well. So the idea of insurance is that there are risks that happen in this world. So you can kind of think of insurance in a very similar way to the way that we thought about the borrowing and lending, is that there's like these two hypothetical situations, right? One in which we get in an accident and one in which we don't, right? And we don't know what's going to happen, so we need to prepare for both events. And so that's why, especially a lot of you guys who live in California, right, maybe have like fire insurance for your homes or earthquake insurance, stuff like that, where we don't know when the accident will occur, but we prepare for that situation so that we aren't completely ruined in the case that it does occur, right? So we say that an accident, so the probability of the bad state, so we call them good state and bad state. That's just kind of like the general simplification. We say that the probability of the bad state plus the probability of the good state is equal to 1, right? And all that really means is that the probability that 2 events occur, right, or that the probability that the bad or that the good occur is equal to 1, right? Meaning that it's going to be either one or the other, right? And that probability is going to add up to 1, okay? So depending on what event occurs, that's going to affect how we consume, right, in either the good state or the bad state. And so kind of what that means is in the case where we do get in an accident, then suddenly we're consuming in the bad state. And that's going to be denoted by C of B, which is consumption in the bad state. So that's if accidents occurs, right? And so this only occurs, right? So this only happens if we get in an accident, okay? And we're going to say that consumption of the good state if no accident occurs. And so I think that the reason why people get tripped up, and this, I still get tripped up, even though I've done this a lot of times, is that it's a very conceptual thing to have, like to kind of think about, because like only one of these situations is going to happen, but we need to prepare for both, okay? And so what that looks like is going to be determined by the amount of insurance that we're going to buy. So um, let's take a situation, or let's take a look at a situation in which we consume no insurance, okay? So if we buy no insurance, then that assumes that our consumption in the good state is going to be equal to the amount of money that we have allotted to us, right? And so you guys already kind of familiar with the term M. So M just refers to our non-wage income, or it just refers to an endowment that we are given, right? This is how much money we have to begin with, okay? So that's what happens when we have no insurance. Um, but in a situation in which we don't buy insurance, right? Well, our consumption in the bad state, which is when the accident occurs, is the amount that we start off with, right? Minus the amount of the loss, right? So M in this case is how much we start off with. L is how much the accident causes us to lose. So you can think about maybe a car. So people have car insurance, for example. M would be maybe like the value of the car, and L would be how much damage the car is inflicted, right, in this accident. Okay, so this is our consumption in both states when we have no insurance. Okay, so let's take a look at a situation in which we have some insurance. Okay, so a situation in which we have some insurance, right, is going to allow us to kind of come up with an equation that's different from like what we have here. So let's take a look at our consumption in the good state. We're going to say that we start off, right, with M, right? In all of these situations, we're always going to start off with M, some amount, right? And we're going to say that we're going to subtract the amount of insurance that we buy, right? So in this case, the amount of insurance that we buy is denoted by this term called gamma K, right? And for those of you guys who maybe are not familiar with gamma K from lecture, or you just need a refresher, right? This is kind of split up into two different variables. So gamma is the cost of $1 of insurance. Okay, and you guys are probably wondering, like, what does that mean to have the cost of $1 of insurance? So if you think about it like this, right, the reason why the cost of insurance is less than how much you're actually covered for is because of the fact that we're not certain that we're going to be getting in an accident. Okay, and so let's say that we're covered up to, say, $500 worth of a loss. Well, we're not going to pay $500 because, or else we would have just paid it out of pocket when we got in the accident. It makes no sense to prepay for something if it's going to be the full amount of the loss. So that's why when we buy insurance, right, we typically pay less than what we're going to be covered for, right? Because of the fact that it's uncertain that we're going to need that insurance, right? So maybe for those of you to kind of maybe provide a more concrete example, um, every year, right? For those of you with like home insurance, every year we pay a premium to the insurance companies, right? And the reason we pay that premium is that in the future they're going to cover us for more than what the premium's worth. But if that accident never occurs, if nothing bad ever happens to your home, then that's essentially just money that you're giving to the insurance company for no reward. Okay, so that's why we pay less than $1 for $1's worth of insurance, right? So this will be some value between 0 and 1 typically. Okay, and so K in this context is equal to the amount of insurance we buy, right? An important thing to note about the value of K is that K has to be some value between 0 and L. right? And so you'll remember that L is the maximum amount that we can lose, right? So let's say that we have a car that's worth $500. The maximum amount that we'll be able to get covered for that car is $500, right? Because we can't buy, say, $10,000 worth of insurance for a $500 car, because if that accident occurs, right, we're getting paid more than what it was worth in the first place, right? So that's why insurance companies aren't going to allow us to do this. So we say that K is some value between 0 and L, okay? So this is where consumption in the good state is. It's going to be the amount that we start off with minus the amount that we pay for insurance, okay? And so let's think about what our consumption in the bad state is going to be. It's still going to be M, right? The amount that we start off with, minus gamma K, right? Minus the amount that we lost, right? Because we still have to pay for it out of pocket and then we'll get reimbursed, plus K, okay? And I want you to kind of think about what this equation means, right? If you just say it out loud in words, right? So we know that K is the amount of insurance that we buy. So that's how much we're covered for, right, in this situation. And so because we know that K is some value between 0 and L, right, that tells us that because we didn't buy full insurance, we lost more than we received back, but we still received some substantial amount, right? So you guys can kind of read this equation out as the amount that we start off with minus the amount that we pay to the insurance company as our premium, minus the amount or like the value of our loss, plus what the insurance company pays back to us, right? So you'll notice that when we get in an accident, the amount that we pay to the insurance company is actually less than what they give back to us, right? And that's because gamma, which is this variable right here, is some value between 0 and 1, meaning that this will be a fraction of this, okay? And obviously you can see that when we're consuming in the good state, so when nothing happens, the amount that we pay to the insurance company is more than we get back because we don't get anything back, all right? So hopefully everything here makes sense so far. Let's take a look at a situation in which we have full insurance. Okay, and so when we fully insure, that's going to make the assumption that the amount of insurance that we buy is going to be equal to the amount that we can lose, right? Meaning that for that $500 car that we have, the amount that we're insuring is going to be the full $500, right? It's the maximum amount that we can lose, meaning that if we do get in an accident, they're paying back the whole value of whatever it is that we just insured, okay? So let's take a look at our consumption in the good state. Our consumption in the good state is going to be M, the amount that we start off with, minus gamma K, right? But notice that because because K is equal to L, right? So this is the amount of insurance that we buy. And because K is equal to L, we can actually just say that this is equal to M minus gamma L, all right? And so consumption in the bad state is going to be M minus gamma K minus L plus K, right? But because, right, K is equal to L, we're going to do the same exact thing, and we're going to substitute our K's for L's, right? And what you'll notice is that we have a minus L plus L, meaning that our consumption in the bad state is going to be M minus gamma L, right? And the most important thing for you guys to note when looking at this equation is that our consumption in the good state is equal to our consumption in the bad state, right? When we have full insurance. And so kind of looking forward to preferences, and I'm gonna demonstrate this later on, is that notice how our consumptions are basically equal in each state. And if you think back to, right, the Cobb-Douglas equations that we had for insurance. Um, that's going to tell us that someone with Cobb-Douglas preferences will probably choose to fully insure because the consumptions are basically the same, right? And now that's not something that is proven just yet. That's something that we'll have to prove, but it's something that I want you to kind of get to thinking about. Um, and so what I want you guys to do is kind of make the connection that basically all we really need is to use this equation, right? Because if we just substitute the values of K for no insurance and full insurance, we'll be able to get stuff like this, right? So you notice that when K is 0, right? When K is equal to 0, then our consumption in the good state here is equal to our consumption in the good state here. And our consumption in the bad state is just equal to m minus L when K is equal to 0, right? So if you don't want to remember all of these equations, you just need to remember the one with some insurance and then substitute the value of K that you're looking for, okay? And that'll get you what all of the different levels of consumption in each state are going to be, all right? Are there any questions about this? I think that this general setup is super important because it kind of tells us how we're going to be able to work through these problems as we move forward, right? And I think, like I've said with all the other kind of budget constraints that we have, if you're able to read through these, like, and say each of these equations in words, that's going to make a huge difference in allowing you to really understand what's going on, okay? So there is an official budget constraint that you guys have probably seen in class, and I'm just going to write it down real quick. But what I will say is that when it comes to actually working through problems, I don't think you're really ever going to need to use it. So I'm just going to briefly introduce it so that it's being recorded and you guys can maybe reference it. But like I said, I don't think that you'll really need to ever apply this. So that's why I'm not going to take very much time with it. So this is the official budget constraint for insurance questions. Right. And I think the reason why you guys probably will never use this is because of how kind of just generally complicated this is. It's hard to really perform any like math on it. And so if you do draw this out, you'll see that you can put it on a graph, right? And the graph looks something like this. So we have this point M right here. So we want to find our different points. And so we know that consumption in the good state is M when we have no insurance, and that our consumption in the bad state with no insurance is M minus L. Right, so this is going to be a point of no insurance. And so we want to find the point of full insurance, and that's going to be M minus gamma L, and this is M minus gamma L. So this will be like right over here. So this is full insurance, right? And we're going to say that everything along this kind of segment is going to be some insurance, and I'll get out of the way, right? And we're going to say that the slope, so slope is equal to gamma over 1 minus gamma, okay? And like I said, I don't think you'll really ever need to use this. I've never seen a practice midterm problem with this. So if you want to maybe just like take a picture and then you just have it just in case it does pop up, then that's, you know, you guys are definitely more than welcome to do that. But I think that for the sake of just being efficient with what you do know, I don't think that you'll really need to know this, right? It's just kind of something that's taught, and it's something to maybe be cognizant of, but not something that you really need to commit to memory. Okay, so we've gotten that out of the way. So from here, I want to talk about the idea of matching our preferences to our like budget constraints, right? We saw that in a case of no insurance, some insurance, full insurance, we had different budget constraints, if you will, right? They are all derived from the same situation in which we have some insurance, right? Because when you have some insurance, you can derive it for no insurance or full insurance, right? Just by manipulating what K is. But how do we decide whether to have no insurance or full insurance, right? That's going to depend on the kind of person that we are, right? And so that's kind of the idea of this whole concept of being risk averse, risk neutral, and risk loving, right? And I think these terms kind of explain, they're pretty self-explanatory what it means, but I can maybe kind of just do it in a context that'll be applied in this class, right? So someone who's risk averse will prefer the safe choice over the risky choice, even if the expected outcome is the same, right? And so what does that mean? There's an example that's used in class, right, where we have the option of either having 500,000, right, for sure, or a million with 50%, or zero with 50%, right? And you'll see that the expected outcome is the same because pretty much the probability of getting 500,000 is 1, so it's 100%, is equal to 0.5 times a million, so like that, plus 0.5 times 0, right? You'll notice that these two are exactly equal because they're both equal to 500,000. But the whole idea of someone who's risk averse is that you prefer this safe choice over this risky choice, right? And so that implies that the utility of $500,000 worth of consumption is greater than the utility of a million with 50% plus the utility of 0 with 50%, right? Which means that this utility function is greater than something like this.
So does risk averse mean that he prefers the risk or that he prefers choosing the safe option?
It means that they prefer the safe option, right? Which means 500,000 in this case is the safe option. And so that tells us that because of this, right, that the $500,000, right, for sure is preferred to the million with 500 or with 50% or 0 with 50%.
Okay.
And so we know that a utility function is basically something that takes an input, right, and produces an output. And so we kind of have to think about what kind of utility functions would make it so that we prefer this over this, right? And so I'm sure that you guys have probably seen it in class, but I'm going to just show you an example of one. And so it'll be something like the square root, right? Anything with diminishing returns will be a viable option for someone who's risk averse. So something like the square root, something like the natural log. I'm trying to think of others. Basically, any exponent less than 1, right? So let's say that, for example, my utility function, right? Utility is a function of consumption, right? It is equal to the square root of consumption, okay? So that tells us that basically any amount of money that I have, I'm just going to take the square root of that and that's going to be how much my utility is valued at, right? So let's apply it to this problem right here, right? So let's apply it to this problem right here, and let's look at the square root. So it should be 1 times, so 1 times the square root of 500,000, right? Versus 0.5 times the square root of a million plus 0.5 times the square root of 0, okay? And you notice that you always have to multiply by the probability of that event occurring, right? So either you get $1 million, right? So that's 0.5, or you get 0, and that's also 0.5, right? So there's a 50-50 chance of each of these occurring, okay? And so if we actually like solve what this is, so just for example, the 500,000, the square root of that is about 707, right? And right off the bat, you know that the square root of a million is just going to be 1,000, right? So versus 1 times 707 versus 0.5, right, times 1,000 plus 0.5, and we know that the square root of 0 is just 0, right? And so this equates out to 707, right, versus 500, right? And so because my utility function has diminishing returns, right, that tells us that this person is risk averse because that'll always result in the safer choice being preferred, right? And you guys could see that it would be true if you took the natural log of this, or if you had just raised it to some exponent that was less than 1, so like 0.8 or 0.543, right? It doesn't really matter. Essentially, someone who's risk averse, right, is going to prefer that safe choice because their utility function looks like that. No, probably not today. So square root consumption, natural log consumption, consumption raised by less than 1, okay? Those are all risk-averse utility functions, okay? So after kind of going through this whole exercise, right, we now need to kind of look at what it means to be risk neutral. So risk neutral, you guys can probably think of a utility function that's going to be fitting for this, right? If I say that risk averse has diminishing returns, well then someone who's risk neutral probably has constant returns. And that implies that there's a linear utility function. So utility of 5c, for example, right? If we take this for just example, right? Utility of 5c. So I take my my inequality that I had before. So you can get 500,000 for sure, right? And so you would multiply this by 5c. So one c in this case would be 500,000, right? Plus, or not plus, we set this equal to 0.5 times 5 times a million, right? And you can do 0.5, so plus 0.5 times 5 times 0, right? But this is just going to equal to 0, so you don't really have to worry about it, right? And so in this case, we'll see that this is equal to 2,500,000, and this is also equal to 2,500,000, right? And so that implies that the safe option is just as beneficial to this individual as the risky option, right? Which implies that someone who's risk neutral is indifferent between the safe choice and the risky choice as long as their expected outcomes are the same, right? So because the expected outcome for both scenarios is 500,000, then this person doesn't really care between the two, right? Because their utility for both of them will be the same, okay? So this is like an example. So any constant, right? Any constant utility function will result in someone who's risk neutral, right? And you guys can already kind of see, right, just based on this pattern, what someone who's risk loving is going to have. If this is diminishing and this is constant, well, then this has to be increasing, right? And so someone who maybe has an exponent that's greater than 1, right, is totally going to fit that bill, right? Or maybe E of C, right? Something like that. So that's kind of like the kind of utility functions that's associated with each person. Let's take a look at what their like the graphs that are associated with this, right? So someone who is risk averse, for example, if you were to just graph out their preferences on a consumption and utility curve, right? We're going to say that someone like this is going to have diminishing returns, right? And so that's basically says that as consumption increases, like the more and more money you have, the less benefit in terms of utility that's going to bring you, right? You're still going to get positive utility from an added unit of consumption, but like the 100th unit of consumption is not going to bring as much utility as like that 10th unit, right? And so let's kind of make some space. Right. If we do the same for a risk neutral person, right, we're going to see that it's just going to be a straight line, right? And lastly, for someone who is risk loving, we're going to say that this is going to be some sort of exponential graph where you're actually going to get more marginal utility from that 100th unit than from that like second unit, okay? So you guys can kind of take a look at these graphs, right? And think about what they mean in the context, right, of how consumption affects their utility, okay? So some more things that I want to point out about someone who's risk averse, for example, is that the utility, the first derivative of their utility with respect to consumption is going to be greater than 0, but that the second derivative with respect to consumption is going to be less than 0. And so what does this mean in the context, right, of this graph? Well, it just means that pretty much any level of consumption will bring them positive utility. Yeah, Sam, this is for risk averse, just to answer your question, if that's what the question is. So if someone, right, is risk averse, then they follow these characteristics. And when they follow these characteristics, it pretty much means that consumption brings them positive utility always, right? You're never going to get negative utility from an increase in consumption. But what will happen is that the change in my utility, right, is going to be negative. Basically saying that, right, kind of what I already said is that there's like a decreasing trend in how it's changing along utility, right? And I've already made that point where the 100th unit of consumption is not going to bring as much utility as that 10th unit, right? And so for someone who's risk averse, let's point out what their characteristics are. The first derivative with respect to consumption is going to be greater than 0, but their second derivative with respect to consumption is going to be 0, right? Meaning that, right, kind of like risk averse, consumption is always going to bring them positive utility, but the marginal change in utility is going to be 0 always, because no matter how much we're consuming, an additional unit of consumption is always going to bring the same amount of utility back, okay? And so risk loving, we're going to see that they're also going to have a positive first derivative, but their second derivative will be greater than 0, right? Meaning that the more consumption that they get, the better off they are, right? So like the 100th unit in this case brings more utility than the 10th unit, okay? So this is kind of what it means to be each of these individuals. You'll notice, right, that you can actually perform these tests, right, on the utility functions themselves. So the first derivative of the natural log, for example, is equal to 1 over c. And this is still a positive amount, right? This is greater than 0. But you'll see that the second derivative, right, is equal to the derivative of 1 over c, right? So this is equal to c to the negative 1. And so this is equal to negative 1 over c squared, right? Where this is now some negative number, right? And that's kind of how you would do this in practice, right? With real life utility functions, okay? So that's kind of what it means to be risk averse, risk neutral, risk loving, right? And so if you relate this back to insurance, and I'm just going to erase this real quick. So if you guys have any questions before I erase, feel free to ask. So Sam, in the lecture example graph, the curve begins about halfway up the y-axis at 0. Is that for the budget constraints of insurance? Is that what you're asking about? For a risk averse utility function? Oh, I see what you mean. So that's, so I'm about to get to that, but that's because the axis here is for utility and consumption, right? The axes on the graph that you're referring to are for consumption in the bad state and consumption in the good state, which is what I'm about to get to right now. Okay, so yeah, the axes are different, which is why the graph's going to look a little bit different. Okay, so I'm going to erase this real quick, and I'm going to kind of get to what Sam was referring to, so that we can make a kind of big connection at the very end. Right. So if we take a look at the indifference curves, so indifference curves for each risk tolerance. So this is what Sam was referring to. We're going to see that someone who is risk averse is going to have a utility function that looks something like this, where it's downward sloping, right? So this is like the perfect Cobb-Douglas ones that we were looking at before, right? Someone who is risk loving is going to have something that exhibits a kind of, what am I going to say? It's not diminishing returns. So this is right where we see these corner solutions. And someone who's risk neutral, right? Their indifference curves are going to look like this, okay? And so these are like the indifference curves for each of these, right? And this is with the axes, right? Remember how in the previous graph, the axes here was consumption and utility, right? But now my axes are switched up, so we have different looking graphs. But you can kind of see how, because these are the indifference curves for each of these risk tolerances, that's going to mean that someone who's risk averse is always going to prefer that interior solution, right? And we're going to make a connection very quickly that basically someone who's risk averse, right? If you remember that consumption in the good state for full insurance was M minus gamma L, consumption in the bad state was M minus gamma L for full, right? If you guys remember what I said about that, that'll kind of indicate that someone who's risk averse would prefer to have full insurance, right? And someone who's risk loving would prefer to not fully insure and have zero insurance. And I think intuitively, that probably makes sense to you guys. But this is kind of just confirmed by the fact that these are the indifference curves, right? Because someone who's risk averse would prefer to have a combination of each of the two, right? Which is what this provides right here. Okay, so that's kind of like sneaking ahead to something that we haven't quite yet proved, but this is the intuition behind why the indifference curves here are important, is because they basically just reaffirm what we would have thought would happen, right? Just based on what the consumption amounts were with the different levels of insurance that we have, okay? So let's kind of move forward just a bit, and we're gonna kind of get to like the whole main idea of insurance, right? So before we move on a little bit further, it's important that we kind of address the concept of fair insurance, right? Fair insurance in this class is going to be when gamma is equal to pi, right? Where gamma, remember, is the cost of $1 of insurance, and pi, right, which we assume pi is the probability of an accident, but you can use a b just to kind of reaffirm that. We're going to say that we have fair insurance when the cost of insurance is equal to the probability of the accident occurring, right? And we know that this is true because if we take a look at the consumer cost, right, versus the insurance company cost, right? We know that the consumer cost, when this is true, right, is gamma k. So this is the amount that the consumer pays, right? And we're going to say that this is, right, we're going to make a relationship between this and the amount that the insurance company is going to pay, right? So the insurance company only pays out when the accident occurs, right? And so the accident occurs with probability pi, right? So pi percent of the time, they're going to have to pay out this level of k, which is how much insurance was bought, right? So like this percentage of the time, they're going to have to pay out this level of k, right? But the other percent of the time, so plus 1 minus pi, right? Basically, when the accident doesn't occur, they have to pay 0, right? There's nothing to pay out, right? And so basically, gamma k is equal to pi of k, right? Which is essentially just saying that the cost to the consumer is equal to the cost of the insurance company when we have fair insurance, right? Right? The k's just cancel out, and we get that gamma is equal to pi beta, or pi of b, okay? And so the reason why fair insurance is important is because we can make an assumption, right? And this is actually based on a proof that was shown in class, but I don't think that it's really necessary to know the proof. But it's essentially saying that when we have fair insurance, right? And this is kind of like the main takeaway of today's lecture, is when we have fair insurance, and so this is important, and a consumer is risk averse, right? They will fully insure, right? So basically, when we have full insurance, we can make this assumption that if somebody is risk averse, then they're going to fully insure, right? You can also make an assumption that when we have fair insurance and a consumer is risk loving, they're going to have 0 insurance, right? And when someone is risk neutral, they can either fully insure or have no insurance, right? It's going to depend on what their preferences are versus the like cost of insurance, right? So that'll kind of be dependent. We don't really worry about risk neutral people in this class. We're basically going to be mainly interested in the difference between someone who fully insures or someone who doesn't insure at all. Okay. Um, so this is like the main takeaway for this class is that um, basically we have this condition here, and we can say the opposite is true for someone who's risk loving. So if risk loving, no insurance, right? And then there's going to be some gray areas that you're going to be tested on. So there's going to be situations in which we don't have fair insurance, and we ask whether they fully insure or not. And so there's possibilities in which you just don't know, right? So, and I kind of want to, leave that open ended because I can't think of like a specific example from the test, but as they come up, right, you'll see kind of how they're phrased. And based on what you know about this information, right, and maybe I can try to find a few questions like that for Wednesday. But I think that for you guys, the main takeaway is as someone who is risk averse and has a situation where they have fair insurance will always fully insure. Okay. And there's like a lot of kind of conditions that need to be met, right? And that's why it seems like maybe this lecture had a lot of different stopping points, right? But that's kind of just to make sure that we were connecting all of these dots. And so I think it's okay to be a little bit confused. The idea of insurance is just inherently a little bit tricky because there's all these conditions that I've kind of mentioned. But don't worry, we're going to answer a lot of those questions when we get to the practice material on Wednesday. I'm going to make sure to bring a lot of good questions about this that we can answer as a class. Are there any questions for me that maybe you guys were confused about something and I could maybe try to explain it a little bit better? If you don't have any questions, you guys are free to go. It's about 1:50, so we're actually ending a little bit earlier today. But yeah, if there's any questions, definitely feel free to ask. Otherwise, I have drop-in hours in 10 minutes, and so I can answer your questions there if you want.
Hi, Eric.
Yeah, hi, what's up?
Hey, so I did really poorly on the second midterm, and I'm not sure if I keep up this score. Sorry, if I keep up this score, I'm not gonna get a B. I was hoping, like, I know you helped me after the first midterm, just kind of ones that I was still stuck on or not sure how I can do better. Do you mind if, like, once I review the stuff I got wrong, if I email you some questions?
Yeah, you can always feel free to like just send me an email and I'll try to answer it as best as I can.
Okay, cool. I mean, I don't want to take up a bunch of your time, but I'm having trouble just like I can't meet any of the office hours. I don't have daycare between 5:30 a.m. and 7:30 a.m. or 5 p.m. and 7:30 p.m. You know,
Is that the office hours for like the TAs and the professor?
for econ, yeah. And I'm a single parent, dude. So yeah, if there's any way, that would just be awesome. I know you helped me a lot with the first one, so.
Yeah. So I don't know if you're able to make it to my drop-in hours, but usually I can answer a lot of your questions there. But
Okay.
also if that doesn't work, you can definitely email me and I'll try to answer as quick as possible.
Okay, I have on Mondays, Wednesdays from 2 to 3, I have class with Ben for statistics.
Okay, well then, yeah, I would definitely go to that because he's super helpful as well.
Yeah, I'm just overwhelmed and everything. Okay, thank you so much. I'll see you on Wednesday.
All right, good luck with studying and everything.
Thanks. Later.
All right. Any other questions, or else I can move on to the drop-in link and we can ask questions there, or I can just hang out and watch lectures, I guess, if no one shows.
What's your email?
I can leave it in the chat.
Great, thank you.
It's